Okay, now the focus of this talk, this is the second of two talks. We had one in the last hour just introducing ML.NET. So this one's going to have different examples, and we're going to focus on this word AutoML. It's now an exciting time, and now people are saying, all right, I can build one model. Can you help me try out several different types of models? And that's what this technology is intended to do. And it's intended to do it for the .NET programming community. So it's a very exciting technology. Sometimes you just want to train one model, but other times you're going to have the use case where you'd want to try several models at once. This technology now is being built out, not only available for the .NET and development community, but also being put behind some of our Azure services. And of course, I'm going to be showing that tomorrow. We're going to have two talks. The first talk is going to be at 12 Eastern, and it's going to be on Nimbus ML, which is Python for using ML.NET. And then the fourth talk will be about automated ML across Azure. And then in that one, I'm going to be talking about Azure ML Service and Databricks. But today, right now, we're going to be talking about ML.NET. My name is Mark Tabladillo. I am a cloud solution architect and a data scientist at Microsoft. I work with the US CTO Customer Success Group, which you can find out more about. Just put that in the search engine. You can find me on Twitter at MarkTabNet. Very active on social media, sharing stories about data science, AI, and many trends. And so happy to be in this group. I founded this group along with Jen Stirrup several years ago, and now we have several thousand members who have opted in to our mailing list, and then people will attend presentations that they find interesting. So again, we have over 100 people attending right now. I can see on their monitor screen. So thank you all for choosing to be here today. The way I like to think about technologies these days, and especially for open source, and by the way, ML.NET and .NET entirely is open source. So there were days when that was not true. Today you'll find all these assets available on GitHub and available for that use. The ML.NET open source momentum, okay, now supported by the .NET Foundation. But if you go to .NET Machine Learning, and again, this slide is a screenshot, it's not actually current like for today, but it shows you kind of general numbers here. 150,000 downloads, how many commits, pull requests, and contributors. So we have people who are contributing to this project. It's active now. 1.0 just came out, and we're hoping that more people will become contributors and be adding to the technology as we go forward. We also have some customer stories about what MLNet has done for them, and I'm going to read this one. MLNet made it straightforward to leverage our existing .NET and C# skills and software assets to add machine learning capabilities into the application. And in this case, this customer deployed on Azure, and the integration of machine learning models was easy and straightforward. And so this is from someone who's in the software development. Of course, we have so many partners that are doing that now. Even this week, after announcing that I would be doing these talks, I was contacted internally by a Microsoft partner. Our group does work with partners, and this one is working with the state government on an application idea. And they have so many people that in their organization, they have 300 consultants working for this partner, and so many of them are doing .NET application, and their use case is to put .NET solutions for machine learning into this application. So they're very interested in that. We're going to actually be talking about that in the coming days and weeks. So it is something that we would love for people to share their story. There's a whole panel about what people have been already doing with ML.NET. There will be a link here, or you could just look for this ML.NET Customer Showcase to see some of the examples of organizations that are using the technology now. And if you are going to be using it, we'd love to have you also tell your story. What does it do? What are its limitations? How has it added value? These types of stories are so important now in shaping this technology. And especially now we're in an open source world, we need to work off of stories of actual use and see what people have in terms of ideas and functionality. Let's talk first here about MLNET Features. Now, .NET is your platform for building anything, and it can be used for, again, desktop is where a lot of it started, but you also can do web, cloud, mobile, multiple mobiles, gaming, and you see on the right now adding IoT and machine learning. So we now have a full range of ways to use .NET. What is machine learning? And it could be the programming, the unprogrammable. So to many developers, a function represents something that they would know, and the question might be, is this a face? Or a different function might be, what is the price of a shirt? How do we do pricing? Pricing is could be a very complicated topic, and especially not just factoring in features of the product itself, but might be also to whom it is being sold, and with what other things that customer might want, in terms of other items or quantity discounts or something like that. So in these areas where a lot of the information is coming from disparate data sources or data sources that are really wide in terms of features, machine learning can provide a way to do that. So machine learning, what does it make? It makes a model. It makes a function. A model and function are the same thing. And here x could be one variable, but often in linear algebra it's written as in vector notation, so it actually represents x1, x2, x3, x4 all the way to x sub n, n as in Nancy. So it could be any number of variables to go in, producing an output. An output would be, this is a face. This is a face. This is not a face. This is not a face. Now, as I said in my last hour talk, they kind of ripped off the animals because those are actually faces to me, because they're animal faces. So showing some animal love, but also realizing that this problem here, as on the slide, is really about human faces. So that's really what we're going for. ML.NET 1.0 was announced at Build 2019, and if you're a developer and you don't know about the Build conference, I would look it up. What is Build 2019? What type of videos are out there? And also presentations, slide decks. A number of things were discussed there, and it's so important to keep up with what is new and being released. ML.NET is a machine learning framework for building custom ML models. It makes it easy, okay, with Model Builder and CLI. Proven at scale, so it's used internally by Microsoft for Azure, Office, and Windows. It's extensible using TensorFlow, Onyx, and Infer.NET, and it's cross-platform through .NET Core. So it can run anywhere that you can use .NET Core. All right, so what's the case for automated machine learning? All right, now this is going to be new slides that you did not see in the last hour. These are the building blocks for a data science project. We often are building training models. Then we do hyperparameter tuning. Every model has these hyperparameters that guide how the algorithm gets to an answer. Then you also have experimentation and pipelines. You have deployment. And then on the right side, DevOps. So cool now with Azure DevOps, which is the renamed Azure service, to be able to deploy models at scale. Full CI/CD pipeline on the right. But today we are talking about just the model creation process. What is automated machine learning? It automates feature engineering, algorithm, and hyperparameter selection to find the best model for your data. I'm not going to fully describe what that is today, so if you want to look this up, what is a hyperparameter, feel free to follow up on your own later, and I'll point you to documentation that describes that. The data scientists know what hyperparameters are. The automated ML missions to enable automated building of machine learning with the goal of accelerating, democratizing, and scaling AI. So what do we mean democratize? What we want to do is enable the domain experts and developers to get rapidly should be built AI solutions. And the use case is that the people who have domain knowledge and the people who are developers might not necessarily be focused data scientists such as myself, and yet they still need to be able to access the power of data science technology. Second here is to accelerate AI. So even for people who, like me, are focused primarily on data science, it provides a technology for testing a lot of models rapidly. And I just remember a contrasting story. I was working for a startup before I came to Microsoft. Literally, there was one day when me and two other data scientists were running to our office and running models on our laptop. And of course, we were running in Linux and we were running in Python, and we were trying models with different parameter settings. And after, I thought, all right, I'll humor this for like the first few rounds. But after we did this for a few rounds, I thought, can't we just write a script for this? And then so they're all like, oh, all right. So, someone went back and did that. But this technology will do that already. So it's already going to test, many operations instead of having to do what we did, spend a few hours in the morning that one time and had several of our data scientists trying out different variations of the model just to see if we could get better results. And then also allows us to scale. So because this can be programmed, this can therefore be programmed to scale. And that means that one can send machines to go do this processing. This picture here is of a data center. And the implication, we love to see you do that in Azure. Test your models and run that. But you also can do it locally. Now today I'm going to be using a data science virtual machine that's running in Azure. It's just one machine and shows that on a single machine, one can still be using these technologies. So here's an example. How much is this car worth? This is the question. Model creation is typically time consuming, and you need to ask, what features do you want to use? What algorithm do you want to use? And what parameters? Parameters are different because parameters have to do with the algorithm. They're tied to the algorithm. Features have to do with the source data, so that's what that process is. And you might decide, I need certain features, I want to go with certain algorithm, I want to go with certain parameters, and then you get an output. Okay, and it might have an accuracy number of 30%. Okay, but you want to keep running that. So you're going to go back and iterate that. You're going to do it again, and you're going to say, all right, next time I run it, maybe I get 50%. And then I keep running it. And then I have this whole grid of results. And as you see on the right side here, we have the best one showed a 95% accuracy rate. And that's comparing the training and the test set. In the test set, you already know the answer, so you train it using your training set, and then you test it where you already know the answer, and then you compare that and you come up with an accuracy. So that's what the process has to do with. So it's going to accelerate your model development. You have the input goals, you define your assumptions. It's going to intelligently test multiple models in parallel. That's the idea here. And the idea, instead of having to rerun this every time with different parameters, as one may often do, it will already do that, a lot of that testing for you. It doesn't mean you have to stop here at 95%. And I always say the best combination to think, the best way to think about automation going forward, just like automated transmission in the car, you still need a person to drive it. All right, so you still need more. You still need a human on top. And even if with a self-driving car, you still have to tell the car where to go. So no matter what it is, there's still a role for humans to play in terms of judging it or determining the values of parameters within which automation lives. The capabilities themselves are based on Microsoft research. They've been trained with several million experiments, collaborative filtering and Bayesian optimization, privacy preserving, no need to see the data. So they have used live data to formulate and shape the approach for how this technology works. And in researching this, I'm wondering, does it always need the cloud to work? And I'm coming up with the answer is no, because what I'm showing today is only running on the virtual machine. I did not set up any Azure parameters to do this, but what they're saying is the choosing of it, the choosing of how it chooses the algorithms or how it chooses the hyperparameters. All of that programming has been shaped by actually running it against live data. That's the point. So the point is the logic behind the automation was driven by real world examples. In other words, it wasn't just someone said, oh, let's just go do this grid of hyperparameters. Actually it's been shaped by, again, live experiments. That's the way I understand it. So the ML scenarios include classification, regression, and forecasting. Someone asked me in the last hour about time series, and so I see it right here in the forecasting. So languages are Python. There's a Python SDK for deployment and hosting for inference on Jupyter notebooks, and that's for the automated ML. Because someone asked me earlier about the ML.NET, and for which you need to use Nimbus. So that's separate. It's starting to get complicated. The training compute, so you can either use a local machine, you can use Azure Machine Learning Service Compute, you can use a data science virtual machine or Azure Databricks. Today, I'm using a data science virtual machine, and I'm using a particular version that's deep learning, which does have GPUs. And then transparency, view the run history, the model metrics and explainability, and scaling. Okay, so that's what it does. Moving on. So you got data pre-processing. This slide just basically shows the steps here of what happens during the process. So that shows, kind of what it does. There are some guardrails here, and this is the slide for the data scientist. Okay, it's going to look for class imbalance, and that means that if you have classes that have small numbers of, now I'm talking about data classes, not programming classes. Data classes that have small numbers of observations, train test split, missing value imputation, high cardinality features, it's going to detect for that. Leaky features would mean that if there's some sort of feedback loop, in other words, inputs that are somehow correlated with the output. Detecting overfitting and model interpretability. This is just the general phrases, and I would look to the documentation to see exactly what is it doing for each of these things. So what is new is I'm going to show this automated in ML.NET model builder preview. So there's a model builder here inside, and you can see the little video here that's showing about what it does. It does scenario, data, train, and we're actually going to do it, so we don't need to see the little graphic video there. But basically that's what it does. So it's going to go through, and it's kind of cool. And it's even going to give you output at the end that you could use. All right, so it comes in these three factors. The three factors, and we're going to show you this for the demo. Command line, graphical user interface, application. So these are the three examples. Oh, we went too fast. Okay, the command line is possible through ML.NET CLI, and you're going to see it. We're going to run it actually in PowerShell, and we're going to have like one-line machine learning. So cool is that? Then we're going to do it through the graphical ML.NET model builder, and then we're going to see the example through a solution that's already built. That's all cool. So let's go ahead and go to that demo. And again, what I have here open and available, let me close the solution that I had opened. But that is what we're looking at is Visual Studio Community 2019. And I have already did a clone of the repo, and it was as easy as just typing in the URL, and it cloned it right into my Windows. This is running Windows Server, And we have here 112 gigabytes of memory. So this is an NC12. And someone asked me about using GPUs. Actually, I don't know the answer to that. I'm assuming it does, but I didn't check it specifically for that purpose. It does appear to be running CPU, though, in this case. So let me go to the... Hopefully it saved my shortcut here. Tutorials. All right. That's for the model builder. Okay, so we'll do the model builder in a second. And this one is for the ML.NET documentation. But what I want to show, if you look on the ML.NET documentation, again, this is in docsmicrosoft.com. Under here is the automated ML preview. Now, I want to mention, this is preview. So right now, I would be a bit, actually for development, it probably does not matter because in preview, you will still get a model that you could test or verify of its correctness before it goes to production. So I have less concern about using this technology in a pure development context. But I would be a bit hesitant to put automated ML into a production solution, which there are going to be people that are going to have use cases for that. But right now, because it is preview, I would kind of wait on doing it for a use for that. But if you see here, there's an ML.NET command line interface tool. First thing it talks about is installing it. And so you run this command. I have already run it for my computer, so you'll already see it's in there. And then, of course, you can install a specific release version, and you can uninstall it or update it. So that's what that first one is. So I'm going to go ahead and start a PowerShell session here. I'm going to run it as administrator. And I think just from there, I should be able to just type MLNet and it will produce something. Okay, and what this means is it is installed and it says required command was not provided. It just means that it's expecting more. So in other words, it identifies MLNet as being a valid command. It's just that I need to put more. But it does also prove that it is installed in my computer. So what I'm going to do is I'm going to follow along this example. The reason I'm showing you this on docsmicrosoft.com is because the demos I show are ones you can start replicating yourself. Like go do this yourself because it's already here. And it shows here that you got your developer here, you got your data sets, and you have the ML.NET CLI. The CLI itself will run on Windows or Linux or Mac OS. All right, so you can use either command prompt, PowerShell, or Bash for this. Today, I'm using PowerShell. Why? Because I'm in Windows Server 2016, and I also happen to like PowerShell. So that's why I'm there. What does it produce? It produces a best ML model. It produces C# code to run the model. And it also produces C# code used to train the model. So earlier when I was saying, you know, the fact that this code or this technology is in preview, if you're using this purely in a development environment, you can still look at the code and you can say, okay, I think that is okay to release to production because I can see what it is doing. So you would be able to assure yourself before you just send something out there to make, you know, some important real world business decision. All right, the tasks supported by this right now are binary classification, multi-class classification, and regression. Future. In fact, it's also suggesting what is the roadmap. Here's the roadmap. Recommendation, ranking, anomaly detection, and clustering. Why is that on the roadmap? Because those tasks are already in ML.NET. It's just that they are not in the automated ML, if you see what I'm saying. So I think that, you know, my viewpoint, if they're pretty close to getting the rest of the set done and to match what is here, MLNet 1.0, then they'll wait for that before saying that this is released. It would be natural that you would need to have a release of ML.NET before you put on the automation layer. I mean, that is logically necessary. ML.NET just went to 1.0. All right, so you do need time between the time the technology comes to 1.0 before you get to a release version. So I'm just showing the logic there in why this is done that way. Okay, so understanding the quality of the model, we're not going to go into details about what these metrics are. I do recommend some training in data science to support understanding what is accuracy, AUC, AUPRC. There is a link here that, if I click this link and I go to a new tab, you can learn about what these metrics are, but these are just like dictionary definitions. There are many videos and so many assets from Microsoft and videos and slide decks out there that describe machine learning and data science in general, but they also show what to look for, like accuracy. The closer to 1, the better. AUC, area under the curve, the closer to 1, the better. And AUCPR, area under the curve of precision recall curve, the closer to 1, the better. And then also F1 score. There are different use cases for why these are important. And right now, just know that these numbers are available through the panel. And you can see here in the trainer, it just shows that how it had run like 5 different models, came out with the best model, and showed that this particular model was done on the 2nd iteration. And then one, that was one from the 19th iteration. Metrics for multi-classification and regression. So let me see here. This is going to be the example I'm going to show. This is going to be the auto-generated binary classifier, and we're going to use it using completely command line. And that's what we're going to do. And it's saying, download the data from this data set. Okay, now let me see if I can remember where I put that. Downloads. I think, no, it's in documents. No, it's not in documents. I'll go back to this again. Let me see if I put a link. I may have put a link for myself on the desktop. No, I did not. Okay. Okay, copy the Yelp labeled text. Oh, I got to find where I put that. Hang on a second. So while that's looking for it, just have to remember where I put it. Let me show again the directions here. It's download. In this example, you download a data set, which I've already done, and you open your preferred command prompt. You go to the place where you put that data, and then you run this auto train command. So right now, I'm going to go ahead and grab this command. No, actually, I still need to find where the data set is. Still searching for it. But I had already downloaded it. Let's see if I can find it in another window. No. Machine learning samples. I think I put it in here. No, I didn't. Sentiment label sentences. Okay, do it again. View folder. Just do it again. Extract to there. All right, here it is, Yelp labeled. All right, I just do it brand new. CD to that. There I am. oh, CD quote to that because there's a space. All right, now we're there. And I'm going to go back to the directions because we're just following directions because literally this is one-liner. So I'm going to, oh, it has a copy button too. All right, so I'm going to copy the button and I'm going to go to PowerShell. And I'm going to press, no, it didn't do it. Let's see. That's not it. Didn't copy it. Let me make sure it does copy it. Copy. I always got to put it in Notepad. Come on. Make sure it got, no, it didn't get it. All right, got to do it old-fashioned way. It didn't copy it. I don't know why it's not grabbing it. All right, I'm gonna have to grab it in 2 pieces. It's not copying it. Sometimes, you know, put those buttons on there and just whatever, the browser's not grabbing it. All right, now I know I got the whole thing. So you see here, MLNet auto train binary classification. Here's a data set. What is the label? Does it have a header? No. And max exploration time, 10. Now I think that means 10 seconds, but I'm not sure. Yes, it says 10 seconds. But you know what? We're going to give it 30 seconds. We'll give them 30 seconds. That's not too long to wait. And while it's running, I'm also going to put this window up so you can see the CPU usage as this is going through. So what it's doing now is it's trying different algorithms. And you see there's a little countdown clock. I said 30 seconds, and it's a good thing because I'm still talking and 10 seconds would have been done. But right now it's at 18, 19 seconds, and you can see this little yellow progress bar going across the screen. Very cool technology. You know, I think a lot of people will be very interested in using something like this. Right now, that's it. You know, give me the best model you can in 30 seconds. That's what this is doing. And it's coming up now here. You can see many of the models have accuracy rates that are right around the same number. And it found its best iteration in number 11. Does it say how many iterations? It doesn't say right here how many iterations it did, but it did say it generated a training model and some other things. So if I do now ls, let's see, it's going to be in the folder. So I'm going to go back to here because this can be easier to see. So what did it make? It made a, and just did this right now, Microsoft Visual Studio solution. It made the model console app, and the model here is stored in this zip file in a format that's understood by ML.NET. So the automation was the part that made this asset, but the assets themselves, they are ML.NET, which is what I was saying earlier. ML.NET is in 1.0, so it's already ready for production. So I could go and open that. I'm not going to do it right now, but that is what it produces. So I think that's very cool. And you see, if you're a PowerShell user, one of the things that I've always loved in talking to so many PowerShell experts, even at Microsoft, is being able to do things in one line. And I am so excited that we have a technology here that can take a data set and train it and produce all these assets in one line. I mean, that's just very cool. So it's certainly something that, you know, for as far as this use case, using the CLI would be something someone would do for development. I would not see you wanting to be doing that for production. You probably want to use some sort of API, which is what we're going to look at next, but not exactly next, because actually we're going to go first to the second example, and the second example is the model builder. So let me go to show the model builder directions. Okay, this is coming from .NET Microsoft COM, and this is the second example. So first one was command line interface, second one now is model builder. You have to install the extension for Visual Studio. So if you go into my list of extensions, and by the way, I love extensions. I love it for Visual Studio. I love it for Visual Studio Code. But you see here, it says ML.NET Model Builder Preview. It's a simple UI tool to build custom machine learning models. So we're going to do the same thing, but we're going to do it using the ML tool. Now it says 10 minutes. We're going to actually do it faster. So you download the extension, and notice at the bottom, if you run into an issue, just hit the button here, I ran into an issue, and you click it. And it'll say, oh, report an issue or provide feedback, and that, it's kind of helping you step by step. But if you're good, you go into next, and then you create your app. So the first thing you do is you go to the console, file new project, and it says Visual Studio 2017, but today I'm using 2019. So, could say 2017 or higher. So I am going to do that from the window interface here. In fact, let me, oh, I just touched the wrong button here. I'll get back to the screen so you can see it. Sorry. Let me go back to this panel. On the other page, I want to put the directions up so that I can see them while I'm typing this in. So let me do that. There's a lot of window manipulation going on here. All right, so the manage extensions is already there. So you're going to watch what I do. So I'm actually following the instructions as they are here. File new project and create a new project. Okay, so you want to choose console app. So that's what it says right here. Notice it calls out that this will run on C#, Linux, Mac OS, Windows, or console. So that's what I want. Next. And then we're going to give it a name. So I'm going to call it My ML App. And PASS. Because I actually did this earlier. So I make sure that we have a brand new name. So I'm going to tap that, create. So it's now creating that project. And notice it's absolutely blank. All right, so now what we want to do is go on the right side here, right-click on the ML project in the Solution Explorer, which is on the right side, and add machine learning. And the reason it's on the menu is because I already added the extension. Okay? Brings up a screen. Pick a scenario. So to generate your model, you'll do this blah, blah, blah. So you want to do sentiment analysis for this one. And you want to download the Wikipedia detox data set to the directory that you had. And so that's part of the download here. And actually, I'm going to download it right now. And you want it to go into the place where it was. So that's going to be documents, I think here. Now let's see where did it put it? Let me go back a screen. Make sure that I understood where it went. I know to go there. Well, no, not there. There, here. Users mark tab source repos. Okay, so it's going to be users mark tab source repos. So let me go back to here. Download the data. Users mark tab source repos, my ML app pass, and my ML pass. And I think it's going to go there. So it's already done. Okay, so that should be fine. Okay, select a file. So, in fact, you didn't have to go there, but you know, you do it for neatness, just to make sure that your information's all together. So there it is, open. All right, and as you see here, it already gives me a preview. It's got sentiment of 1 or 0, 1 meaning negative and 0 meaning positive, but it's based on this sentiment text. Okay, so I added my data, and select the file. We did that. Use a column to predict select sentiment. So here we're trying to predict the sentiment based on text. So this is like a text mining example. Okay, so next, train. So now it's going to give us the time to train, and just like last time, I'm not going to do 10, I'm going to do 30, give it 30 seconds, start training, and we're going to go. There we go. And we can see, you see the output log down here on the bottom, very cool for the data scientist because you can see what's going on, plus the CPU usage on the screen. So it's trying all these models, bam, 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 bam. In fact, in this particular case, again, this is a demo example. So don't think that every model is going to take like 5 seconds to train, because that might not be true. What I could see this as being very useful for is, even if you had big data, you could take a sample of your data, you could run it through automated ML, and could suggest what types of models to train. Possible. Depends on, you know, how good that sample is. All right, so it's already done. You see on the bottom is an output very similar to what we saw in the CLI. No surprise, because it's kind of the same code. And then it has an accuracy number, gives you the best algorithm. Okay, so now we're going to evaluate, how do you understand the results? This chart is the same, I can see now, but an advantage of the one in the output, it shows the iteration number. Of course, that was dropped. The iteration number was dropped on the GUI. Add machine learning projects, so I'm going to just press that. And you see on the right side, what it did is, you can see the model. The model's there, and also the code to do the console application is all there. So there it is. It did it. So what it did is it produced a model that had the best result. And in this case, it was called SGD calibrated binary. That was the first one. I'm noticing right now, because this is in preview, the documentation is a little bit light right now about what these things are. So again, you're navigating into curious waters if you want to, you know, do this on your own. But know that you can always ask a question from the team. Now, the .NET machine learning team has a way for you to talk to them. Let me go back to, is that this page? Yes, Gitter. So on the GitHub website, you can go ahead and go to Gitter, and this is what they're using for you to ask questions if you have questions about this technology, because again, the documentation's light. All right, so I'm going to close that solution, saving it. And then I'm going to go back to machine learning samples. There is also an example here that's available, and there is something you have to do. Now, because this is a new implementation of Windows, they didn't have the graphics pointing to a viewer. So if I try to click a graphic, let's see. No, let's go to a different one. Let me drag this one. The graphics didn't go to a viewer. So what happens is these examples don't finish, because the last thing it does is produces a graph. All right, so actually right now it's going to paint, and that's good enough. Okay, we'll find out what happens. All right, so it's going to paint. I'm going to go ahead. I open this example. I'm just going to pick the sentiment analysis again, run it. Oh, let's see, something went wrong with that. All right, let me do another one because I'm not going to try to figure out why that didn't work. It did work for me earlier, so. Oh, let's just run the last successful build. Why did it exit? Let's see. Let me do it again. Oh, this is a .NET thing. So sorry about that. The current .NET SDK does not support targeting .NET Core 2.2. Why? Because it's not installed on this computer. So I had, I'm not going to do it now because we are coming up on the end of the hour. I'd rather take some questions. But I noticed that the deep learning virtual machine doesn't have the version of .NET Core to which these solutions are targeted. So it's not that hard. You just install .NET Core 2.2 and then everything works fine. So I'd rather save this time for some questions and also talk to you about the last few slides, then go ahead and finish that example. But that was the third example of running it from an application, and you'll be able to see all that code came from GitHub. So you will be able to run that as long as you have the .NET Core 2.2 installed. So you would have to go ahead and do that. Okay, let me see. That's the other deck. I don't know where. Okay, let me go back. I'm gonna have to open the deck again. Nope, not that deck. This one. Lots of controls. Okay, let me go back to the screen where we were. That's where we were. All right, advanced features for .NET. If you didn't know, there is a .NET for Apache Spark, and that will be used for distributed processing. Just know such a thing exists. And also know that for real-world situations, I recommend going to the .NET architecture guides, looking at the latest advice about putting solutions into production. And then in terms of action, there will be a slide here about getting started, trying the samples and the docs. And of course I showed where a lot of that is. We do have some time for questions, so I'm going to go through and see the questions that we have here on the panel. And feel free just to, if you have a comment, just make a comment. Okay, videos are going to hopefully be published today. You will get an email. So the email I will send as soon as I get the videos uploaded. They go into post-production and then translate in MP4, and then we put wrappers around them, and then we upload it to YouTube. Okay, how can AutoML be used in Azure? Lovely question, and this is the second of 4 presentations. Presentation number 4 tomorrow is going to be about more ideas about using AutoML in Azure, and I'm going to be showing it with Azure ML Service and also with Databricks. So this is not the only way to do it. This is a way to do it. And we are now in a world where it's not like one desktop app does all my AutoML. So obviously this is not even a desktop app. It's just code. It's code that can run in the CLI. It's code that can run in a .NET application. It's code that someone can put a GUI, just like you saw I put the GUI, the model builder GUI, is if you're a .NET developer, you could build a GUI for someone and put AutoML behind it. Okay, how about doing that? And so that's the type of world we live in now, but I will be talking about that tomorrow. And how to use the data science virtual machine. Let me answer that question. The virtual machine is of best use, in my opinion, as a development platform. And you can see here, a lot of software has already been loaded into the virtual machine, including Python, including R. You'll see Jupyter, you'll see RStudio, Power BI Desktop. And what I would do is go to the Microsoft documentation and look for what they're putting in the current build. That is the best thing I can say. The image will change. And we could log on tomorrow and they decide to implement a new image of Windows. And typically, actually, I use Linux the most. However, because I wanted to show everything today for .NET, I wanted to make sure people see the Windows experience, which is why I chose that for today. And I think also that's how many .NET developers would be using it, even if they deploy on Linux. All right, after AutoML trains a model, can we find out what hyperparameters it picked for the best performing model? And the answer, I think, will be yes. However, I have not looked at it myself. So what I would look at is the assets that it produces in that folder. You know, when I showed this earlier, oh, go in there. Okay, so it shows the model and solutions. I have not studied this to see exactly what's in there, but this is where it will be. It'll be in the assets that it produces, because that's really all that matters. All right, is there any recommended sources for understanding the data science terms for somebody new to ML? Wonderful question. We do have, let me go back to docs. Okay, if you go to docs.microsoft.com, you'll see a number of resources here, including video learning, MSDN, TechNext, startup students. And inside here is a lot of information about learning about .NET and also even ML.NET. So ML.NET, you know, it's got its own bullet. But if I click, this is what I want to show. If I click here, Start Learning on the top, and I want a learning path, and I go to the role, you'll see that data scientist is one of the roles here. And by the way, it's not the only one. You can also learn how to be any of these other roles. But this is the one I would start with, the data scientist role. I've done these courses myself, and they continue to come out with new ones, so I don't know if I've done all the latest ones. But there's a lot of interactive online training from Microsoft, free, and just go do it. So here we have a lot of things here about, you know, Azure machine learning. This one here, Introduction to Data Science in Azure, excellent course. Okay, someone was cluing me to use shift arrow earlier. Thank you for that. How does it know which columns in the data set to use for AutoML? So they're described during the process, and I think it's taking all of them, and there may be an exclusion parameter. I'm not sure about that. You do know that this is preview, so let me answer it this way. If they're, like earlier when I was using the model builder, all it was asking me is, what is your output? And then I think it was assuming everything else is going to be an input and already ready to go. So it's going to have to be in a certain format, you know, for that model builder to build it. So functionally, I would make sure that that data set only has what you need, and, you know, strip off things like IDs and things that are not going to be useful for feature prediction. So that's functionally what I would do right now. How can we get explainability for ML models? That is still in preview. I have not understood it fully myself, but I do know that that is one of the features here. Let me see. Okay, I would go to the documentation here, explaining model predictions using permutation feature importance, there is a page that talks about that topic. And the feature importance is going to show you, how important certain features were in the model. This technology is part of the ML.NET, so that would be the answer for that. Does AutoML generate the code for how it handled missing data or skewed data? And again, I don't know the answer to that. I would just look at the assets. So let me go back actually to what the assets were. This is the solution I built earlier, and let's open it and let's just see what's in there. Closed solution. I'm going to look at the, oh, actually it says, just go get it. There it is. So what did it show me? Let me see this here. What is it showing here? Okay, so there were several questions, and I didn't show it in this deck, but there are three ideas. One is data, second is transformations, and third is estimators. And what it's doing here is it does show some of the transforms right here, I'm looking at it, about what it did. So normalized min-max, for example, is one of the transformations that was done. So everything that it did shows here in terms of code. So you start from the raw data set. Any transformations or anything that it did to the data is part of the code. And this is what I would expect it to do. Can we train different hyperparameters for deep learning models? And I don't know that it has that type of flexibility right now. The automated ML, you see that I didn't imply what parameters I wanted to use. And earlier, as I was telling the story, when this technology was being built, they coded that based on training many, many models. So it's not like you, have that freedom to do that. Now, what will be interesting to me is to be able to peek into the code, since this is open source, and see how they achieve that, because one could always write a wrapper around ML.NET and then have that technology automated. So it's nothing preventing somebody from writing an automation around ML.NET, but this particular technology has already been automated in the sense a lot of things have already been abstracted, including like choosing the hyperparameters. So I'm just describing the way it works. If you want to have a conversation with the team, I would love for you to engage them on Gitter and go ahead and talk to them about how you're using ML.NET and what you're thinking about it. And I noticed here Rajesh wrote the answers, wrote some of the questions earlier that we had talked about working with Keras and the GPUs. And that was from the last hour. Okay, I'm going to continue here. I know we're a bit over time, but we'll only have a few more questions that I haven't seen. Okay, let's see, shift arrow. Next one. Can ML.NET AutoML can be stored in SQL Server 2017 and then used by Python? Okay, that's an interesting topic. There is a way to call C# from SQL Server 2017 without using Python, period. Okay, that's first step number one. So know that that was already possible, but the part B about using Python, and the answer there will be yes, because Python runs with SQL Server 2017, and also, by the way, look at 2019, SQL Server 2019, and that would be through Nimbus ML. Now, what is the better way to do it? I don't know that answer. I mean, someone would still have to go through both ways and weigh the advantages and disadvantages of running it through Python versus running it through C# for SQL Server. So those are some things to consider. All right, so tomorrow's sessions, someone's asking me about tomorrow's sessions, and if you go to datascience.path sandstatpass.org. That's the front door to signing up for tomorrow's sessions, if you want to do that. Do I still have it up? I know I have it up on one of these screens. I just don't know what screen. Sorry. No, not that screen. Okay, I'm not going to try to bring up the screen. datascience.pass.org. When you run the train to the model builder, what happens in the back end? Is all the code running part of the final model project, or is it coming from ML.NET components? It's coming from ML.NET. So the automation is completely on ML.NET. AutoML, all it does is provides a wrapper for running ML.NET. And I see, I'm reading, is all the code running part of the final model project? No, it's not running the final model project is the result of testing many models and deciding which is the best one. So once it decides that, then just like it made in the solution I was just showing before, this model here that produced, I don't know if you can do properties. All right, properties are down there. It just shows you where it is, but that zipped model is the best one that was produced in the time frame that I gave it. And I only gave it seconds. I mean, obviously, if I gave it longer, would it do better? I don't know. Depends on the data. It can only do as well as the data. In other words, you can't just let these models run forever and get to 99% or whatever. It depends on the data. The data is going to max out on how accurate it is in showing a signal. And hopefully that could be detected through the best algorithms. So hopefully that answers that question. For hyperparameters, look in Model Builder CS for a line starting with var trainer. Thank you. So let me go back to Model CS. Somebody tell me where the line is. Because I don't know where the line is. I'm still learning this technology myself. So let's see. Var trainer equals. Here. So someone says, if I look at this trainer model, here it will be. Oh, and there it is. Thank you very much. So somebody said, if you just look at the trainer line right here, line 59, in my case, might be different for yours, but you can see what L2 regularization, the convergence tolerance, there's 3, 4, 5. Well, actually, these are not hyperparameters. They are just settings. So I would say number of iterations might be a hyperparameter. So it might be only 3 here for this particular model, but these are the values. Thank you for that. Justin. Can AutoML be used for deep learning? And the answer is, I think that was on the roadmap. I don't know that that was announced, but let's see. Go back to here. All I can see is what we have here on the list, and go back here. Okay, actually, I don't know the answer to that offhand. The documentation in this section is actually where I wanted to see the most, because here ML.NET is very well built out, but then they tease us. They give us this preview of what everybody really wants to see, which is automated ML preview, and I'm not seeing enough here. But again, go ask your question on Gitter. Go to Gitter, ask the team that's producing this roadmap and everything else. Could not find the session link. Okay, so let me give you a session link. Hang on. And this is for tomorrow. Okay, here's what you want to do. You want to register, and this is the path of registering through the PASS website. It is not direct link to GoToWebinar. Okay, so this is what I'm still suggesting because this is our front door. The GoToWebinar link, that was the side door. So this is where you want to register for that link. We're going to talk tomorrow about introduction to Nimbus ML, and that will be to train Azure Machine Learning or anywhere else Python, anywhere else use Python. Someone asked a question today about SQL Server 2017, and of course that would be a place to use Python. So this technology would work with SQL Server 2017. And then later on, this is going to be tomorrow, overview of automated ML, and this has to do with ML, automated, the same technology we're showing now, except in Azure ML Service and then also in Databricks. So those are places that we'll see it. And again, I'm going to go back to general questions. If you have any questions about this ML.NET technology, put it in here for Gitter, because this is an active board. You can see even today people are having conversations. And many of the questions have already been answered. So go ahead and scan through, especially if you're using this right now. I know many people in this presentation and the last one are looking to do solutions right now. So don't wait. I mean, I'm not most in the know about everything about this technology, and I am a user. I am a advanced user, maybe, and I want you to be an advanced user too. And where I would go is right here and ask those questions. Okay, and so that's all I have today. And so thank you for again attending this session. I'm going to stop the recording, and I hope to see many of you tomorrow. And if you're not able to attend, go ahead and go to YouTube once I post the links for the videos. They will all be in the same channel in YouTube, and that's where we're posting it. And then the slide decks, I'm going to be posting to SlideShare. Thanks for attending today.